How to determine possible outcomes, or let's say the combinations, in easy way? This trick is applicable to binomial distribution, meaning those objects that we have to use would only result true. For example, the coin, head or tail, or the phone, iOS or Android, or let's say sex, the male or female, or we can use also color, two colors, white or black. Let's take this scenario. Three coins are tossed. How many possible outcomes can you think of? And list them without confusions. Maybe in our mind, we can think head, tail, or the three coins, tails, or heads. But how sure are you that you can completely list them all in a short time? I mean, in this way. Let's try this trick that I have to introduce to you, adapting the binary systems or binary numbers. Okay, let's say we have to let T for tail and H for head. One possible result of the event, if we're going to toss the three coins, it's labeled that one to A, B, and C, head, tail. Okay. Three coins are tossed. Step one, we have to draw columns respectively from right to left. Coin A, B, and C. Since we have three coins, so we have to draw three columns. And we will adapt now the concepts on the binary system or the conversion of decimal to binary numbers. So 1 from right to left, 2, you just multiply that 1 by 2. Then 4, and so on. So we will disregard the remaining 8 up to whatsoever because we will only use the three columns. So 1, 2, and 4. 1, 2, and 4. So we have this one, the binary numbers, or the easy way to convert decimal to binary numbers. Take note that binary numbers only use 0 and 1, base 2, and decimal, base 10, 0 to 9. And step 2, we have now to level right to left, 1, 2, and 4. This one, 1, 2, and 4. Step 3, after that one, meron tayong 1, 2, and 4, we have to add all the numbers. 4 plus 2 plus 1 equals 7. And we have to include 0. So meaning, we have now 0 to 7. That is 8 possible outcomes. So the total of the coins, 3 coins tossed, is 8 possible outcomes. But what are they? Can we list them in a short time without any doubts or confusions? So let's proceed to determining the possible outcome or the combination. We have now to list the possible outcomes, the total starting from 0 to 7, 8 possible outcomes to the left. Yeah. Then we have to let, and this time we'll not use H and T, so we will have to let 1 for H for 1, T for 0. So we'll use 0 and 1. So we'll now go and adapt the binary numbers. Decimal to binary, add all applicable numbers. Here, you have to add. So assign two coins A, B, and C to satisfy the number 0 to 7 here. Write 1 if true, we will use that one, otherwise 0 if not. For example, to make it easy, we have 0. We cannot add 1, 2, and 4 for the 0, right? So this is false. So we will put 0, 0, 0, 0. Take note, that is T for 0. Okay, next, you have 1. We will complete this table. You have the idea? 1. We have the here, right? So we will use 1. So it is true, 1. Then the remaining columns says, 0 and 0, because we only use 1, right? How about 2? This one. We can see 2, so we will write 1, this one, 2, and then 0 and 0. 4 coin A and C, 0. Because we only use the second column. How about 3? Okay, we cannot see 3 on the label 1 to 4, right? So we'll find numbers that sum to 3, 2, and 1. So we'll add it 1, 2 plus 1 is 3. So we will put 1 and 1, and then disregard, and we will put 0 to the not used label or number. How about 4? Okay, we can see 4. So we put 1, 0, 0. Then 5, 4 plus 1, 4 and 1. It is 1, 1. So 1, 0, 1. Next, we have 6, 4 plus 2, 6, 1, 1, 0. Because we didn't use the coin A, 1, so we will put right 0 on the top. And then, the last is 1, 1, 1, 4, 2, and 1. Here, here is the complete list of the possible outcomes. But we can only see in this table 0 and 1. So we have to replace, substitute the H for 1 and tail for 0. So we will have, I replace already the 1 to H, and then T for 0. So we have now the list, complete list of the possible outcomes of the event that we're going to toss 3 coins. And if we're going to list this one in a substitution in the list, we call this one as sample space. T, 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 H, T, H, T. We have 8 possible outcomes, 0 to 7. 3 coins are tossed. We have the possible outcomes combination here. 1, 2, 3, 4, 5, 6, 7, 8 possible outcomes. Okay, you can go for less than 20 minutes challenge. Okay, now you will deal with 5 coins are tossed. Or you have to try 4 if you have no enough time for that. A sample space is a collection of set of possible outcomes of a random experiment. So if we're going to list that one, those possible outcomes, we call it is called sample space. And we have to say random variable if we're going to take regard or count that, for example, you have to represent the number of heads that occur. So that is random variable. Okay, we have to count that one. How many heads? that occur on that outcome or combination.